Alright, so let's begin. So today's kind of our review week, or this week is our review week. Okay, so I thought we'd start off today going over your lab that was due last week. So we'll talk about our strings lab, and then we'll talk about the homework problem that was due last week. And then I thought we could program a program together, kind of as review. Do one from the book. And then I'll give you the rest of the class to work on your loops lab. And your homework that's due, I forget when they're due, Friday. Yeah, Wednesday and Friday. And then on Wednesday, as promised, we'll have Jeopardy review. So on this Wednesday, we'll have a review using Jeopardy. You can acquire points in Jeopardy. Okay, we do random name picker. I pick your name, you pick a point and a category. And then if you get the question right, you get to have those points toward your test. Okay, so study for it. I, as promised, put that quiz for Chapter 4 and 5 in here. You have a couple weeks to take that one. And then you could go back and take your old quizzes. They should let you take them kind of as review. You could take those Chapter 1 and 2. Here's the Chapter 3 quiz. And then we have our Chapter 4 and 5 quiz. Okay, so you can go in there and for Chapter 4 and 5, I did narrow down the questions so that it wasn't all the questions from our test bank. It was just the ones that, are more pertinent to what we've learned. Okay? All right. But let's go over your strings lab first. Now, you guys already turned this in. All right. In fact, does someone want me to use their answers?
Sure.
Okay. We'll use your answers. Let's see. Your last name is... What's your last name?
Meza, M-E-Z-A.
Oh, Meza. Okay. There you are. Ding, ding, ding. There we are. Cool. That's what the grade book looks like. You've never seen a grade book. Okay, cool. All right. All right. So in your strings lab, you worked with strings. And you guys test some things out. I guess some things to remember about strings is remember to always visualize them as a box holding all of your characters. And each of those characters has an index value. We went over that a couple times, but that's important to understand strings and to use the string functions properly. Is that you had to realize that each character had an index value in your string. Okay, remember it starts with index 0, and then index 1, index 2, index 3, index 4. And you can think of them as a single unit called an object, but it is comprised of or made up of characters. Okay, strings. That was the important part to realize there. And then to realize that we had lots of string functions, and whenever you want to do something with a string, there most likely is a function that will help you with it 99.9% of the time. You're going to find a string function that will help you do what you want to do with your string. Okay, and that's called string manipulation. So whenever you're doing string manipulation, remember to use a function, right? Use a method. Right? And in this lab, I had you, test out some of these methods. And then finally, we got to a question in here after you tested them out. Right? Where's my question? I hid them. There they are. Okay. So we are testing out our substring function. And then our first question said, explain in your own words what the substring method does. In Java, we do call our functions methods. Okay, but in other programming languages, we call them functions. So sometimes I will call it a function. but method's the same thing, okay, another name. Such as what does it return and what its argument is. Answer should be a couple of sentences, okay. So one thing when we're using these functions, methods, is that our methods can return one thing or nothing. Maybe you guys noticed that. It either can return something to the program or it doesn't return anything to the program. And so a lot of these functions, these string functions, returned a new string that was changed back to your program and then you had to store it somewhere, right? So this returned or gave you back a string that was a substring of the original string, and then you had to store it in the new string variable. Okay? And then when we were talking about arguments is what went in the parentheses. That's your argument. And so what does the substring method return to us? We can check Lithia's, but what does it return to us? What do you guys think the substring? You guys tested it out. Kind of remember what it returns to you? Remember, it returned a smaller string. It was a smaller string. It was a substring. You know, a smaller string of the original string. Okay. Let's see what Lithia put. She put this method of substring as one variant and returns a new string that is a substitute of this string. The substring begins with the character at the specified index. We use the number 3 and continues to the end of this string. Okay, that sounds pretty good. The return value is the specified value. Well, the return value is the string, and we use the number 3. All right, so our return value is actually our substring. So it returns the substring. Yeah. So it does return a string to us, a substring. It returns the string to us, and that's what we're storing right there. Okay. But it was pretty. She wrote it pretty nice, you know. I know you guys are beginning programming, so I don't expect perfection in these answers. Okay, so as long as they're pretty okay. But you should have told me, hey, yes, it does return a string, and she did get what the argument was correct. This is the beginning index of where you start that substring. So if my string was hello, H is at index 0, E is at index 1, L is at index 2, the second L is at index 3. So it starts at index 3 and goes to the end of the string, so it will return LO as a little mini string into substring. Okay, so it makes the string LO and puts it into substring.
We probably went through this when we were talking about strings.
Yes.
But, so basically, when you're talking about variables, and like, you know, you said number, your variable is number, and then your variable equals something.
Mm-hmm.
And with strings, what they did is it took different, like, indexes, and it saved little small chunks in your
Yes.
space. But my question is, how do you let your computer know what size of chunk to save? I guess, does that make sense?
Right.
Because like with some you do an int, with some you do a double, with some you do a float.
Oh yes, with strings. Okay, so that's a good question. You know, with an integer, you know you want to save 4 bytes of memory. And with a double, you know you're going to set aside 8 bytes of memory. But with a string, it is a variable size. Okay? Strings are stored a little bit different. So that's why I brought up Excel to kind of draw a picture of how it stores them. I don't remember if we did this in here. Okay. But it's good to go over it again anyway. So let me just make some RAM. Actually, we'll zoom in a little bit here. I used to draw these on the board, but I found I do much neater work in Excel, so we use Excel to draw our RAM. Excel is great at drawing some RAM. There's some RAM. Remember that when we have RAM, they are given address values. So, you know, your computer gives them address values, and they're lined up. Now, usually these address values are hexadecimal. We can pretend this is hexadecimal. Actually, we can make it hexadecimal. I mean, it saves it as ones and zeros, but a lot of times we represent it with hexadecimal numbers. Okay, so everything in your computer is still... Now remember, in hexadecimal, when we run out of digits, we use the letters A, B, C, D, E, F. All right. So here's some RAM locations. There's their memory addresses. And let's say we write in our program something like this. Int number equals 6. All right. So let's say we write something like this, and I'll make it bigger so we can see it in the back. If I write something in my code like that, it's good to realize what goes on in RAM. This is a good review. We're reviewing this week anyway, right? So remember, if I write something like this, what it does is it goes and it finds a memory location that has 4 bytes of memory available to me. It then names that memory location number in the background. We can think of it as naming that memory location 123 number. It then takes those 4 memory bytes, right? We can fill it with something to show that now they're taken. And it puts the number 6 in there. So we can even merge and center and put the number 6 in there. Now this is abstract. It does store it as a binary number, but we can think of it, hey, it stored the number 6 in there. Okay. When we do a double, it does the same thing. It sets aside 8 bytes instead of 4. Now when it does something like a string is an object comprised of characters. Okay? So when it stores objects, it's called storing something by reference. Okay? So this is a primitive type variable, and then a string is an object or reference type variable. Okay? So when I write something in my program like this, when I write string, my string equals the word hello. Okay. What it does is it goes and it finds memory and it puts my string right here. Okay. But it doesn't store the characters right here. What it stores is a reference to where it's going to store the characters in memory, because for exactly that reason it doesn't know how much room that it needs. Okay? So it goes and it finds, let's see, 2 times HELLO, 2 times 5, each character is 2, right? It'll find 10 memory locations to store this thing. We'll think of each of these as 2, size 2 maybe, or whatever. But it goes and it finds some more memory, wherever memory it is. Let's say we start at 145. Okay. And it goes and it puts the H in there. And then it goes and it puts E over here. Actually, lowercase e. And Excel's getting rid of my other apostrophe. Okay. And then what it stores at my string is it stores the memory address of this H, which is at index 0. Okay. So what he stores inside of my string is actually a memory address.
So kind of like an icon.
It's called a pointer or a reference variable.
But is it the same idea as an icon? Kind of?
I'm not really sure what you mean by icon.
Because like when you open your desktop, you see the icon.
Oh, I guess the software, it is kind of like a reference. Yeah, that would be a reference. That is a reference, yes. Exactly. Yeah, that makes sense. It's like the icon is referencing something else. It's located somewhere else, the actual files.
So the 4 bytes is like somewhere else.
Mm-hmm. And so it actually points to this place in memory where the array of characters is stored. Okay? So that's why when we write things like this, let's say I have another my string. I call him my string 2. he'll go and make my string 2. Okay. And he makes my string 2 look just like the other string, but he's in a different place in memory. And then I have to make some more memory locations here. And I'm counting in hexadecimal to make it more realistic. But pretty much this is at 14C. That's what memory address it's going to store here. So now he's pointing to a different place in memory. And that's why when I say my string equal my string 2, what am I checking? I'm checking to see if this memory address equals this memory address. Like when I write things like this is why we can't check strings this way when we want to check their actual values. When I write code that looks like this, my string equals my string 2, remember that checks equality? But it goes to this memory location, goes, okay, this memory address, does it equal this memory address? And even though their values are the same, it's not checking the values, it's checking the memory addresses.
It's checking the size of the memory.
Not just the size, the actual address in memory. Remember that this actually points to a memory location address. Remember, every RAM location, every RAM box inside of your computer has its own little address.
So where each is, it's actually assigned the value of an int. But it stores
the location of the first index of your string. Now remember that these, and this is a good review too, remember that these are all indexed then. This is index 0, 1, 2, 3, 4. And the reason that we do that is so that we don't have to think about memory addresses. It just does it for us. If we had to program actually writing down the memory addresses, it would make programming harder. So we just say, okay, you store the memory address, I'll just use this word. And when I want to get a hold of this character, I'll just say mystring.char at 1, and he knows to go here and go to the first index and get that character for me. Okay? Like if I were to write something like this, remember? So mystring.char at index 1. If I write some code like that, it goes, okay, go to mystring, follow his memory address to here, move down to index 1, and give back that E.
And the spaces, they save them as, what do they save them as?
As a space character.
Because does it save it as a byte also? Or does it say, okay.
Yeah, so white space, he said, how does it store white space? White space is the same as any other character. It stores it the same way. Okay. So it's good to have this visual. When you're programming, you have to have visuals like this so that we can realize, because sometimes we do want to check to see if memory addresses equal each other. When we get into data structures and things, this comes in handy. In this class, we don't really worry too much about it, but we do have to realize that, hey, our characters are stored over here, and that's why we can't use equal equals. Okay? So, if you can visualize what's going on in your computer, it helps you with all these computer science algorithms and what's going on in there. So, all right. Okay, cool. All right. So what that substring method does, you can kind of think what it does visually. If I were to write something like this, my string dot substring, start at index 2, it goes to my string, goes and finds index 2, and returns LLO as a new string. So it puts the LLO together as a new string and returns that to your program. It's like the user typed in LLO. Okay? That's what it's returning. So, the answer to this question, that was kind of a long answer, but that was good. Our substring will return, actually it returns LO because our index was 3. So it started at index 3, returned LO as a new string, and then put that new string inside of substring. So substring's now pointing to RAM where LO is stored. A new LO, not the original LO. It's a brand new LO. Okay? And then when you're printing it out, it knows to print out that string LO. Okay? Any questions on that one? All right. A lot of those string methods do return new strings, new string versions. All right. What if you had a string as the one below? So a Benini is yellow. And you wanted to replace the letter E with the letter A. What method would you use? And so you had to either look in Eclipse to figure out that method, or you could look in your book, or you looked online to figure it out. But remember, if you put that dot operator in Eclipse, actually I think it's the first one that it says or suggests, right? And which method was that? Yeah, replace. Okay. Now you could have done it other ways, but replace is the easiest. And what did the replace method do? Yeah, it replaced all the E's with A's. Right? And so when you ran that, actually, here's our... This is a good answer. What if you had a string blah, blah, blah? Oh, okay. I don't think you used replace here. You used substring. You used substring. Now, you could use substring, right? But I think it would be more than just one line if you had to use it.
It would be wrong again. You'd have to...
Now, if you put replace, it would be wrong again. Now, I didn't say it was wrong, but you guys might have noticed that was wrong. Because when you put all the E's with that replace method and you replace all the E's, it says the banana is yellow. Now, the only way that you can get it to do it correctly would be to take this as a substring, replace it, replace all the E's with A's, take this as a second substring, and then put those two substrings back together.
Wow. Yeah, because, when I read that question, I thought it was asking for just change the banana. So I was looking for that. That makes sense.
Yeah. In fact, do you guys want to code it real fast, or? Okay. You can code this one really quick. It is, I think, beneficial to see how it works. So if you had a string, the Benini is yellow. Or we should just call it new S. So you take that S and you put that dot operator. Remember when you put the dot operator in Eclipse, it brings up all of your string methods very conveniently. Okay. And there's the replace command, or replace method. You can read about it. Like if you click once on him, you can read what he does. At first, some of these things might seem a little cryptic, but the more you read them, the more they make sense. Okay, and this is how you learn a programming language. You have to read these. But it returns a string resulting from replacing all occurrences of old char in this string with new char. Actually, that one reads pretty well. So you can see that it takes two parameters. You're going to give it two arguments. They're called parameters here, and when you write them, they're called arguments. Okay. So the first parameter will be the old character, and the new character will be your second parameter. So when I was coming around, a lot of people had this right. So remember, you put your old character, and then your new character. And remember that it's replacing it and returning a new string, so you had to store that new string. And then when you went to go print them out, and it was fine if you just gave me this answer like this. This would be a good answer. Okay. I didn't expect you to fix it not to say yellow. Okay. But it does give you the output. The banana is yellow because it replaced all the E's with A's. Okay, because that's what we told it to do. Remember, computers only do what we tell them to do. So we told it, it said, okay, yeah, I can do that. Okay. So what if you wanted to only replace this guy and not this guy? Okay, I kind of told you how you would do it. Let's count our indexes. We're going to have to do a substring, substring, replace this substring with the A's, and then stick them back together. So this will be index 0, index 1, index 2, index 3, index 4, 5, 6, 7, 8, 9. Okay, so we want to go up to index 9. Okay, that'll be index 10 right there. So you could make a string, call it first half, or front half, or something to that effect. And you could say s dot substring. Here's our beginning index, ending index, substring thing. Could start at 0. And I think it's exclusive of the ending index, so I'm going to put 10 in here because we want to include index 9. And then we have to take the second half. S dot. Now notice there's two substring methods. There's one substring that you take the beginning and ending index, and then there's one substring where you just take the beginning index. And the one that you just take the beginning index automatically goes to the end of the string. So I could say, okay, begin at index 10 and go to the end of my string. And then I would, instead of replacing S here, I would replace front half, all the E's with the I's. And then I would have to concatenate or stick together the front half and the second half. Remember that our plus operator works with strings as it concatenates or glues them together. It works right to left, or left to right, I mean. It glues them together. And so then we can run this thing. And, oh, I put front half here, not new S. I was like, what? We need to put new S because that'll be our new front half. Right? And it does indeed say the banana is yellow.
What you? Oh, the new S in place.
Yeah. So the new S, I should have put new front half, but I was kind of lazy. I just kept them as new S. Okay. Remember, we can name our variables whatever we want. And sometimes when I'm working quickly, I don't name them that great. Okay, but that would be one way that you could do that, and that's how Java demands that we do that. Remember how we thought about how to do that? You know, you just think, okay, I got to get the front half, you got to split it, you change one, and then you put it back together.
What would, if you put the and sign on there? So,
The ampersand?
Yeah, the and.
Where?
On the new S and second half.
What do you mean? Like, because remember the and is like a Boolean operator. It's a logical operator. Maybe you could show me after. Okay. All right. All right. But your answer to number 2 didn't have to be that whole substring thing. That would be extra. Did anyone do that actually? Did anyone fix it properly? That's okay. That maybe sometimes some people do. But the answer would be, hey, it would be the replace method. Okay, so you should have told me that it was the replace method. And you should have just showed me that it looked like this. Right? All right, so I was just using a method. All right, and then I had you guys run this program from your book. And it says, what is the method next double return? In other words, what's the value that the next double method gives back to the program after it's executed? This was actually a really easy answer, so hopefully everybody got it. What does next double return? A Double, yes. And if you put a decimal value, excellent too, that means a double. But if you told me a double, that's a great answer. Double or a decimal number, okay, typed in at the keyboard. Okay. Now note that next double doesn't have to be typed in from the keyboard, but we're using the keyboard input right there with the input. Okay. When we're reading from files, we can use next double too. All right. Number 4, which class does the next double method belong to? Now you could have figured this out some, different ways. You could have looked in your book. They would have told you. You could have looked at this code. The code will actually tell you which class it belongs to. Eclipse will tell you which class it belongs to. Which class does it belong to? Whenever you're trying to figure out where a method belongs, look at the object that calls it. That's the class it comes from. So when we look at the input object is a scanner object. So that means all of his methods come from the scanner class. So you should have told me it came from the scanner class. Okay? So you should have said, okay, next double method belongs to the scanner class. And then number 5, which object is calling this method? You should have told me the input object is calling this method. A better answer would be the scanner object is calling this method, because input is just his variable name, but he is of type scanner. Okay? And you can think of it, just as we name people. We have a teacher, we have a student, we have a police officer. Police officers have certain methods that they do. Students have certain methods that they do. Turn in homework, do your homework. Instructors have certain methods, I do. You can kind of think of that as an analogy. A scanner object has certain methods that he does. The scanner object's job is to get stuff in from the input. And so this was he's a scanner object. His name is input, but he's a scanner object. Remember that we can name this whatever we want to name it. Sometimes we name it keyboard. You can name it whatever you want, usually just with a lowercase letter. All right. So any questions on those? Number 6, I did actually make you look at the API, look at the Application Programming Interface, or API, for the scanner class. And then there was 2 methods in there. You could have looked in your book too, the difference between next and next line. Okay, so this is our API. As you get better at programming, you'll come here more and more. And at first it might look cryptic to you again. Some of my students are like, oh, this looks very confusing. But it really is not that confusing, and the more you look at it, the easier it gets. Okay, all programming languages have an API. And the API just has all the directions, it has all the methods you can use. And it has all the information that you need. And so in here, if you scroll down, there was a next method. And then there was a next line method down here. And if we read what the next method does, it says it finds and returns the next complete token from the scanner. A token is a program or a computer science term meaning like a word. Okay, so it returns the next word. Okay, so next returns a word to you, where next line, if you read what next line does, advances this scanner past the current line and returns the input that was skipped, meaning that it returns the entire line to you. So next returns just a word, and next line returns the entire line. Okay. So you can think of next as what's called its delimiter is white space. A delimiter means where it stops. So when it's reading in characters, it gets to the white space, it stops. So next delimiter is white space. Where next line, its delimiter is the end of line character. It reads into the end of line character and then stops. And that's important. That'll help us debug lots of things in our programs, if we remember that. All right. So hopefully you told me that next reads in a single word, or next delimiter is white space. You could say either of those things. And next line, hopefully you told me that next line reads in a whole line of text, or its delimiter is an align character. Okay, so something to that effect would have been a good answer for that one. All right, number 7. I had you guys, oh, you know what? I figured out later that I actually wrote, or I think when I changed this to a PDF, it changed it wrong. It's funny I didn't get more questions on this. But the is the number was supposed to go to this line, but it still kind of would have worked. And the point I was getting at here is that our code doesn't work when it's like this. All right. So let me demo that. Actually, I'll leave this in here and I'll upload this code later. So we tell the user, actually, SYS, to enter in some text, right? And then we had a scanner. Do I have a scanner anywhere? I don't think so. Okay, we had this guy. And then, let's see here, what did we take in? We took in an int, and then a next line, and a next line, and then we outputted those things. Okay, so we had our int num equals keyboard. Actually, I'll just use my copy paste here. Dot next int. And then we had do a next line. And then we had another next line. And then we just outputted all of them, right? So we'll output our num. Okay. And then we'll output our 2 strings. Alright, so I kind of expected you guys to make this test program. Alright, and when we run something like this, I wanted to test it with some different output. And actually in the book he goes over why we have a problem here. Let me have this up. So in the first example, or the first input, I said, okay, write 13 space is the number, and this is a line of text. So we write 13 is the number, and this is a line of text, and everything seems great. It gives back to us the num is 13, S1 is the number, S2, and this is a line of text. Everything looks okay. It's as we kind of would expect it to look, right? It took in the integer, and then it takes in the string, and takes in the string. Everything seems great. But then if we run it again and I hit 13, or any kind of number, enter, and then I put this is the number, enter, and then it spits it out at me, and it says, it didn't let me put my last line in there. This is a line of text. And it says my number is 13 and S1 is nothing. And this is the number. What happened to my S1? What happened to that next line? And see, this happens a lot actually. And sometimes when this happens to students, they tell me, I've been debugging this for 8 hours and I can't figure out why it's skipping my next line. Okay, this happens in lots of programming languages, not just Java. It happens in C++ and different languages. So this is why we go over this in here, so that you won't be banging your head against the wall for 8 hours, right? Okay, so it's not skipping that line. What's happening is there's an end of line character right here. When I type 13 enter, the end of line character is here, you just can't see it. The little /n thing, it's here. It's hidden, right? So then when I said keyboard.nextInt, it grabbed the 13 and put it in num. But the end of line character is still there on the keyboard buffer. He's still right here. So then when I said S1 keyboard.nextLine, it grabs the end of line character and puts it into S1. And then when I typed in this is the number, it grabbed in this line of text and put it in S2. So this will always happen to you when you grab an integer or a double or any kind of number that doesn't take in the end of line character and you hit enter and you have a next line, the next input's the next line, it'll look like it didn't grab any input. But it really grabbed the end of line character. Okay? And this will happen, and it seems like there's a bug in here. But there isn't. It just is working the way it's supposed to. And so one way that you could fix this, that a lot of books will say to fix this, is to actually put an extra keyboard.nextLine in here. Right here. Don't store it anywhere. And what that does is it grabs the end of line character and then just does nothing with it. Okay, and that'll help fix this problem. And you can see it when I run it again. Okay, and I put in here 13 is, 13 enter is the number. Enter, now look at, see, it didn't put the, it took the end of line character, threw it away, and now put is the number inside of S1. And this is a line of text. And so now it did it correctly, or it did my input the way I wanted it to. All right, yes, Eric, or Jason. What do you mean, the original input? Oh, right here? Oh, yeah. So that one will actually work also. So let's run it. Well, actually, now we've broken the first one. So when we put 13 is the number and we do the original line of text, now it's waiting for another line of text. Okay. And do you see what happened? This part then went into that keyboard.nextLine that does nothing with it. So you only kind of need this fix if you're going to enter in a number, hit enter, and then the next line is going to enter in a line of text. Okay? All right. And that's just kind of a weird error, but it does drive students crazy, and so we go over it. So then hopefully you remember, if it ever is skipping a next line, this is why. You'll remember that, hopefully. Okay. This happens a lot. The first time it happened to me, I was like, oh, you know, and then you remember. But, I did write this question wrong, so I'll just not count this question as part of your lab. I don't know if the PDF did it wrong here, but I wanted this is the to be on this line here.
So you wanted us to notice that
that it would skip that line.
Because it saves the
end of line character. Still on what's called the keyboard buffer. So the way your operating system works is when you type stuff in, it goes into like a little buffer, like a holding area with everything that you've typed in. And when we tell input to go and retrieve those things, it goes and looks in that keyboard buffer, finds the number, brings it back, but leaves the end of line character on the buffer. And then when next line goes there, it says, oh, end of line character, I got it. It comes back. Okay. So it's operating how it should. It's just, you know, sometimes it doesn't seem that way. Okay? All right. But that was the point of that last question there on our lab. I spent way too much time going over that lab, but that's okay. Any other questions on our lab? All right. Let's just go over your homework problem that was due. Actually, Lucia, do you want to share your homework problem since we didn't really use your homework? No?
Oh, the homework problem?
Yeah, the homework problem. I know you did that one okay. I think I saw it.
Yeah, use it.
Okay. Eh. Since we didn't really use her lab strings. It was homework 4, programming problem 13. It was the homework problem that you just last had, which was distinguishing your characters, a consonant and a vowel. Oh yes, you did use the case statements too. We'll just put it here. Now, since we're doing it, remember to always name your classes with a capital letter. Okay. I don't take off points in the beginning here, but we do need to get better at that. By the end of this semester, I do take off points for not capitalizing your class names. It makes our code more readable. It's standards. It's good. And I know why you put this, that whole keyboard thing, but I'm going to take it out. Now remember also you can get rid of extra lines. So if you have like more than one line separating your code, you can delete those extra lines. And we could look at more than one person's code, but a switch statement was a beautiful way to do this program actually. So remember that most of you will have this part in your code. You should have asked the user to enter in a letter. We didn't have to check to make sure it was a letter. I said we don't have to do error checking. She went ahead and took it in as a string. And then she actually used her switch statement here by pulling out that character right here. She didn't give it a variable name, but she pulled out the character right here. That does pull out the one character that's in the string, and you can treat it as a character. And then she had some switch statements in here, so we can look at how she created this. So if it was an upper or lowercase a, she put is a vowel. Upper or lowercase e, she put a vowel. And she put her break statements in there. Remember how a switch works? If I typed in an E, capital E, it would come here and say true, and it would keep executing code till it got to a break statement. So do you realize that you can actually take out this line of code and take out these lines of code, take out these lines of code, take out these lines of code, and your code would actually still work the same way. Because all those lines were repeating. If it's an A, E, I, O, or U, like let's say it's an O, it'll come here, it'll keep executing code, it'll print this out, and then get to the break statement and leave. So the way you wrote it was excellent. It's a great way. It's correct. But you could actually write it this way too. Okay? It's good to see. It's good to see the two different ways. And this helps us realize how a switch statement works. Okay? For any of these cases, because there's nothing there and there's no break statement, they'll all come down. Print is a vowel and break. Okay? If it's a Y or a Y, or sometimes a vowel and then break. And if it's anything else that doesn't match any of those cases, it goes to the default. And so what prints is a consonant.
Probably forgot about why.
And sometimes why.
It's okay if you forgot about Y. I don't ding you for Y. Because for words like my.
Sometimes sounds like a vowel. Sometimes.
Because every word has to have a vowel in it.
Oh my god.
And so like the word my and by.
English has no rules, guys.
American English.
But they taught you you're supposed to lie. English has
So
no
this was
rules.
a good answer. Excellent. Perfect. Okay. Indented right. Looks great.
Did you look at mine?
Sure. Let's look at another one. Did you do if else?
Yeah, I
Okay. Let's look at an if else one then. Let's see, your last name is an A. Oops, dang it. Oh, right there, yes. Okay. We can look at an if else because a lot of people programmed it with if else. That's the thing about programming. You can program a program many different ways. Okay? That's kind of the beauty of programming. Now, is one way better than the other? Sometimes. Sometimes in programming, one way is better than the other just because it's more efficient. or it compiles to less assembly language code in the end. Okay, and when we get into data structures, we can see that some code will take hours to run, but you program it more efficiently, it takes minutes to run. In this programming class, we don't really get into efficiency all that much. In the second level, we do. But this looks like, oh, this is awesome. So he used the OR operator. Okay. So you could have wrote lots of if-else ifs, or you could have used the OR operator like how he did. Okay. Which is doing the same thing that the switch is. Okay, more or less. So he takes in his letter. Perfect. He gets the character. He makes it into a character. It pulls out the character out of that string and stores it. And then he actually used an OR statement. So he had his Boolean statements connected with these ORs. So as long as one of these Boolean statements was true, it would make the whole Boolean statement true. Now you didn't check, oh wait, you didn't check for caps because, did you make it lowercase? Now you wouldn't have to check for capital letters if you made it to lower, right? Did I write that right? Next. Dot. Oh, to lowercase. There we are. So, to make his code all the way work and not check for capital or lowercase, you could convert that string it takes in with the string method to make it lowercase. So you could use the lowercase method to make it, or you could check for both, upper and lowercase. I saw some people just check for both. Either way, they're all right answers as long as it did what it was supposed to do. And it's good to see different ways of doing this.
So in this case, you can put a capital A, it would say it would be a consonant.
No, it would take, if I put this to lower, then it won't say it's a consonant. Because what it does is it takes in that A as a string, makes it lowercase, then takes that lowercase letter here, and then you only have to check for lowercase letters. Okay? But that's excellent. We used our OR and combined them this way, our Booleans. This is another way that we could have written it.
So if you actually typed in a capital A, it would just convert it to a lowercase.
It does it right here, yes. It takes in the capital A right here. And that capital A then calls the to lower method, and it makes it lowercase. Okay, cool. That's a couple different ways. If I see more or some other different ways, I'll post them in our answers folder. I got to start posting our answers to our programming problems. I'll make it answers folder in Blackboard, so then you could see other ways to program it. Okay? All right. Man, we wasted so much time on that. Okay. But that was good. So, you know, good job on our homework in our lab. Any questions on our homework or labs? Actually, since we spent so much time on that, I think we'll just skip programming, an extra program, and I'll just let you guys work on your labs right now. Okay? So that way, I'll just post an extra program you guys can look at. All right? And then on Wednesday, like I said, we'll do our review. So let me pause.